In a parking lot in Beijing, an American journalist watched a family sedan plug into a charger and start drawing more than 1,000 kilowatts of power. That is roughly the instantaneous electricity draw of 1,000 homes flowing into one car through a liquid-cooled cable light, enough to hold in one hand. In under 5 minutes, the battery went from nearly empty to 60%. The company behind it is BYD, the largest electric car maker on Earth. In March of 2025, it unveiled a charging system peaking at 1 megawatt. 1 year later, it raised that to 1.5 megawatts at 1,500 amps and announced it had already built more than 4,200 of these stations across China, with 20,000 targeted by the end of 2026. For comparison, the fastest public chargers in the United States top out around 500 kilowatts, a third of that figure, and there are only a handful of them in the entire country. The headlines say, China just made charging an electric car as fast as pumping gas. That claim comes with real asterisks, and we are going to be honest about every one of them, because the honest version is more interesting than the slogan. But the physics underneath it is not marketing. Something genuinely changed here, and once you understand what, you will understand why the last practical argument against the electric car is quietly being dismantled. Start with why this number matters at all. Surveys and sales data keep pointing at the same psychological wall. People will accept that an electric car costs more up front. They will accept finding chargers. What breaks them is time. A gas stop takes 5 minutes. A typical fast charge takes 30 or 40. That gap, more than price or range, is the moment the electric car still feels like a compromise. Wang Chuanfu, the founder of BYD, has said the goal in plain words: make charging as quick as refueling a gasoline car. Kill the last excuse. And the West has been stuck on this exact problem for a decade. Tesla's newest supercharger cabinets reach 500 kilowatts, and the first complete station at that power opened in California only in September 2025. Europe's big networks, Ionium and the rest, mostly run at 350. The hardware to go faster exists in labs and truck stops, but for ordinary passenger cars, the practical ceiling across America and Europe has sat around 0.5 megawatt. So why did everyone stop there? Because of one inconvenient law of physics. When you push electrical current through a cable, a connector, or a battery, you generate heat, and that heat does not grow in proportion to the current. It grows with the square of it. Double the amps, and you get 4 times the heat. Triple them, 9 times. This is why your phone charger gets warm, and why a fast-charging car battery needs serious cooling. At the currents a megawatt requires, the heat becomes a monster. Cables thicken until a person cannot lift them. Connectors cook. And inside the battery, something worse happens. Push lithium ions into the anode too fast, and they stop slotting in neatly and start plating onto the surface as raw metal, which permanently kills capacity, and, in the worst case, grows needle-like structures that can short the cell from the inside. That is the wall. Not regulation, not willpower. Heat and chemistry. It is why the entire Western industry settled around 500 kilowatts and called it enough. BYD attacked the wall from 3 directions at once. First, voltage. Power is voltage times current, so BYD built the entire car, battery, motor, electronics, even the air conditioning, on a 1,000-volt architecture, the first mass-produced passenger platform to do it. Higher voltage means you need fewer of those dangerous amps for the same power. Second, resistance. The company re-engineered its iron phosphate blade battery with what it calls ultra-fast ion channels, cutting the cell's internal resistance roughly in half by its own account, so less of the incoming energy turns into heat in the first place. Third, the hardware. New in-house silicon carbide power chips rated for 1,500 volts and a charging gun cooled by circulating liquid, which is how a cable carrying 1,500 amps, around 100 times the current of the circuit behind your wall outlet, stays light enough to lift with one hand. But here is the part almost nobody talks about, and it might be the cleverest piece of the whole system. Even if the car can drink a megawatt, the grid cannot pour it. A bank of megawatt chargers would hit a neighborhood's electrical infrastructure like a small factory switching on and off every 5 minutes. Under the conventional approach, every station would need its own substation grade connection, which is precisely why ultra-fast charging has crawled in the West. BYD's answer was to put a battery inside the charging station itself. Each site carries an energy storage buffer that sips from the grid slowly, at roughly the power of a normal fast charger, then dumps that stored energy into your car at full force. According to an independent teardown analysis, a 1 megawatt flash station can run on a grid connection of only around 200 kilowatts. The station fills its tank quietly all day, often on cheap off-peak power, and empties it in 5-minute bursts. No new substation, no grid upgrade. That single design choice is the reason these stations can be dropped into existing parking lots by the thousands. There is even a confession hidden in the hardware. The first flash charging cars carry 2 charging ports, not 1, because in 2025, no single connector could safely carry 1,000 amps, so the megawatt actually flowed through 2 plugs at once. The same trick lets these cars combine 2 ordinary chargers anywhere in the world into one fast session. By 2026, BYD had engineered a single gun that handles the full 1,500 amps on its own. Watch the connectors, and you can see the technology maturing in real time. If you are finding this as fascinating as I did when I dug into the engineering, subscribe to the channel, because now come the asterisks, and they matter. First, peak is not average. In BYD's own demonstration, the car held a full megawatt for only about 70 seconds before the rate tapered, which is normal physics for any battery. Averaged over the whole session, the charge rate was closer to 500 kilowatts. Still roughly double anything a Western passenger car sustains, but the 5-minute headline describes the best window, not the whole curve. Second, the range numbers. 400 kilometers in 5 minutes is measured on China's testing cycle, which is famously generous. Real-world range is meaningfully lower. Third, that Beijing session was a demonstration run by BYD, witnessed and reported, but not an independent instrumented test. And fourth, the heat question is not fully closed. In one independent livestream, a flash-charging BYD's battery surface hit 76 degrees Celsius, above what battery engineers traditionally considered the safe ceiling for this chemistry. BYD's battery chief publicly pushed back, saying the old limit reflected old materials and that the cells are validated for 1,000 full flash charge cycles. Maybe so, but that is a manufacturer's claim, and the long-term durability data simply does not exist in public yet. BMW's head of battery production put the skeptic's case in one image. A battery is like a blanket. Pull hard on one corner and it comes off somewhere else. Speed, lifespan, cost, safety. You do not get to maximize all 4. Those are the honest caveats. Now hold them against what is verifiably happening on the ground, because this is where the story stops being about one charger. In March of 2026, BYD reported 4,239 flash stations built across China. By the 1st of April, 5,000. By late May, more than 6,100. To hit its target of 20,000 by the end of the year, BYD needs to open roughly 55 stations every single day. The plan splits in 2. Around 18,000 will be dropped inside existing charging sites, which the battery buffer makes possible without new land or new grid capacity, and 2,000 will line the national highways, roughly 1 every 100 kilometers. And all of this lands on top of a country that already operates around 2/3 of all the public chargers on Earth, a fast charger fleet that grew by 40% in a single year. In June, BYD signed a deal with Sinopec, China's largest fuel retailer with over 30,000 gas stations, to build flash chargers inside the gas station network itself. The petrol stations are installing the thing that replaces them. And to prove the system works anywhere, BYD has run public demonstrations at a station in the Tengger Desert and at a site near Mount Everest. Then comes the second punch. In April 2026, BYD announced 6,000 stations outside China within 12 months, including 3,000 across Europe, starting in Germany, France, Italy, Spain, and the United Kingdom. And critically, they will be open to every brand through the standard European connector. A Volkswagen driver in Munich may get their first taste of megawatt-class charging from a Chinese station in a Chinese network. The marketing slogan BYD chose for Europe tells you exactly how confident they are. Ready in 5, full in 9, cold, add 3. And BYD is not even running alone. CATL, the world's biggest battery maker, has shown a cell that charges even fast. Huawei has a 1.5 megawatt charger for trucks. Zeekr built a 1.2 megawatt unit before any car could use it. This is not one company's stunt. It is an entire industrial ecosystem racing itself, while the West's megawatt efforts remain focused on trucks and prototypes. Which brings us to the real story underneath the wattage. Because the remarkable thing is not that BYD built a powerful charger. Anyone can build one powerful charger. The remarkable thing is who got to design the whole problem. BYD started in 1995, not as a car maker, but as a battery company, and it never stopped being one. It makes its own cells, its own power chips, its own motors, its own chargers. When Warren Buffett tried to buy a quarter of the company in 2008, the founder turned him down and let him have 10%. That obsessive self-reliance means BYD could redesign the battery, the car, the cable, and the station as one single system, each piece compensating for the others. Western automakers optimizing one component at a time are not slow. They are structurally unable to play this particular game. The specification can be copied. The system that deploys it 50 times a day cannot, at least not quickly. So no, charging is not universally as fast as pumping gas yet. And the physics of that comparison is worth 30 seconds because it recalibrates the whole debate. A gasoline pump moving 10 gallons per minute is transferring chemical energy at a rate of roughly 20 megawatts. No charger on Earth touches that, and none will soon. But a combustion engine then throws away 3/4 of that energy as heat, while an electric motor uses nearly everything it is given. Measure useful energy, the kind that actually moves the car, and the gas pump's real rate falls to a few megawatts. Suddenly, 1.5 megawatts is not a different universe. It is the same neighborhood. The gap that defined a century of transportation has shrunk from 100 times to a handful, and it closed almost entirely in the last 3 years in one country. It is that fast for specific cars, at specific stations, in the best minutes of the charge curve. But the wall everyone said was physics turned out to be merely engineering, and the engineering is now rolling out at industrial speed. 5 years ago, the question was whether an electric car could ever refuel like a gasoline one. That question has been answered. The only question left is how long the rest of the world takes to catch up to the answer. If this changed how you see what is actually coming for the car, subscribe. There is a lot more to show you.